This is Unit 6, Section 6.2, exploring the areas of circles and sectors. So last time we looked at area formulas for many objects, so the rectangle, square, parallelogram, triangle, trapezoid, and circle. Today we're going to continue the idea of circles, but also look at sectors, which is part of a circle. So recall, if we look at what is the area formula for a circle, we get pi r squared, where r is our radius. Man, that kind of looks like a potato, sorry. Okay, so here's our circle with radius r. So if I take pi times the radius squared, it gives me the area of that entire figure. So example, can we find the following bold figures? Okay, so this is everything colored in here. So we have area equals pi. Radius is 12, so I'm going to fill that in and square it. Go to my calculator, and this says to give exact answers. So that means leave it in terms of pi. So when it tells me 144 pi, that's what I'm going to keep it as, with centimeters squared as my units. On number 2, I have my radius, so I can plug into my formula. Pi 8 is my radius, so I substitute it in. And 8 squared, I get 64 with that pi coming down. And this time my units is meters squared. So those two are very quick because they're just right given to us and going with the formula. On number 3 though, now we just want this piece of the circle. So how much of the circle is this of the whole circle? And so I see this as a quarter because we have 90 degrees and this has been split into 4 things here. So I'm going to take my area and say I want pi radius, which is 13, squared, but I want to divide that in 4 because I know that 90 degrees is 1/4 of my circle. So when I plug this in, I get 169 pi over 4 as my exact answer because I have that 4 when I divide because I want 1/4 of it. And the units here would be centimeters squared. So now we just took not a whole circle, but a portion of a circle, 1/4 of a circle. Okay, so what about on number 4? We have 13 again for our radius, but now I want 270 degrees to get this part out here. So when I look at this part, now I see if I divide it into fourths, instead of 1/4, now I want 3/4. So 1, 2, 3. So on our previous day, we did a semicircle was half, 90 degrees is a quarter, 270 is 3 of those quarters. So for the area, I'm going to take pi r squared, and then what I'm going to do is multiply by 3/4 because I only want 3/4 of this, not 4 of the quarters. So it's going to make it smaller than the overall circle. So when I multiply that out, my calculator gives me 507 pi divided by 4. And my units here, feet squared. So the whole circle is that 169 pi. And then when I multiply it by 3/4, I get this value. So what about on number 5? How many degrees do I want is 105, but how much of the entire circle is that? How do we get the 3/4 or how do we get the 1/4 like on number 3? So what do you think on this one? How should we find the area of this sector here? All right, so that comes into our new definition of a sector. We can find some of them just using our prior knowledge of an area of a circle, but a sector is a part of a circle or a portion of it. I always like to think of it as like a slice of pizza, or if you're ready for dessert, a piece of pie. And so when we look at this, how do we know and how do we find that area? The area sector of a circle is just a portion of the entire area. So the way we do that is we say, okay, how many degrees do you want out of 360 of the pi r squared? So when we want 90 degrees out of 360, like on number 3, okay, that means we want 90 degrees. We don't want the whole 360 because 360 divided by itself would be 1, meaning we want all the pi r squared. But 90 divided by 360 simplifies to that 1/4, which is what we did on number 3. 270 degrees that we would want out of 360 would simplify to the 3/4 that we wanted on number 4. So if we look back at number 5 here, what do we think? Well, I think I want 105 degrees of those 360 times the pi r squared. So I want 105 degrees of 360 of the pi 7 squared. So when I put that in my calculator, where I have 105 over 360 times pi and 7 squared, and it tells me that this area would be 343 pi over 24, and that would be centimeters squared. And so when we change this, instead of trying to guess like, oh, is it 3/4, is it 1/4, we can just say, well, how many degrees is it? That's the proportion that I want out of 360. So our formula says, how many degrees do you want? If I want the whole circle, well, that means I want 360 out of 360, which is all of the pi r squared. For anything less, I'm going to just set up this proportion in front, or ratio in front of the circle. So let's check these on the other side here. Now that I want to find the area of the sector, so the colored in portion here, B to C, they're telling me is 16, so that's our radius here. So once I have that, I can say, well, I want 51 degrees out of that 360 times the whole circle, pi r squared. Put this in my calculator, and I get 544 pi out of 15, and my units on this one, since it's feet here, will be feet squared. So the area of that sector is 544 pi over 15 feet squared. On number 2, okay, we have P to Q is 22, so again, that's giving us our radius. And the area formula for that sector, I want 139 degrees out of 360 times pi, our radius, squared. A lot of this is the setup and then relying on our calculator, so carefully enter those in and make sure that we're copying that down correctly. So here's our solution. We have 16,819 pi out of 90, and that unit is going to be centimeters squared. Okay, on number 3, J to K. Okay, so again, that's giving us our radius here. And we can find the area by saying we want 84 degrees of our shaded area here of the circle pi r squared. Go to our calculator here and I get 756 pi out of 361, and that is going to be millimeters squared. I almost said times, but that's just of. There you go. On number 4, okay, G to H is 13. There's our radius. Oh, be careful here because that 126 is the angle over here. We want the angle over here. So I'm going to do a quick calculation and subtract that 126 to see what's the angle of my shaded, and I get 234 degrees. So I don't want 126 because that's not what's shaded. I want 234 degrees out of 360 times pi r squared. Then when I set that up, I can put that in my calculator using the 234, which is on this side. On my calculator, once I get that, I get 2,197 pi out of 20. And the units on that one is yard squared. Ooh, kind of drew through my thing there. Careful. All right. So be careful. On 84 now, I almost want to go back and check. 139, 51. Okay, they were giving us the shaded angle. This is one where they did not give us the shaded angle and we had to do a calculation. So let's look at number 5. If this is 90, okay, so how far is it around on this side in the shaded? So if I take 360 minus 90, that's where I get the 270. All right, and then M to N is 29.5, so that's where they give us the radius here. And so on my calculator, I will take our 270 degrees out of 360 that we want, so we don't want the whole circle, and then times pi r 29.5 squared. And again, double check this on your calculator. I get 10,443. And pi divided by 16 is my exact answer, measured in miles squared. So that's big, 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 big. This is not drawn to scale. And on our last one, number 6. Okay, so E to F, we have 4.7. So again, on each of these, they gave us the radius and the units here instead of in the picture. Now this part is 341. So what is this angle? So let's do our calculation. 360, good grief, minus the 341, and so when I subtract that, I get 19 degrees. So if I did the 341, that would be a significant amount of the circle. I only want, for the area, 19 out of the 360 degrees of the entire circle. So when I plug this into my calculator, notice that it gives me a long running decimal. It's because this didn't end up as nice as the 29.5, where we could convert that to a fraction. 4.7 squared is not as friendly. So we'll get an approximation here, decimal without pi, that says it's 3.66 kilometers squared. So even though the directions on this said to give an exact answer, that's as exact as we can get to the nearest hundredth because we can't round, or because we're already working with a decimal that's been rounded. Let me know if you have any questions on circles and sectors and working your calculator, making sure you're getting the same values as I am, or if you need any help with that. Have a good day.